Hello guys, and welcome back to Easy Stats Tutoring with ND. And if you're new to the channel, please subscribe and hit on the notification bell so you're notified when we drop another video. Without further ado, let's get into today's video. Okay, so in today's video, we'll be doing analysis of variance, which is ANOVA in short, and this is study unit 4, part 2, continuing from what we did in part 1. Okay, so ANOVA has three assumptions. So that's what we're going to start with. It has three assumptions, which is independence. We are assuming that the group means the groups are independent. And then we also assume that there is homogeneity of variances, like the spread of the data within each group is the same as the data in the other group. And then there's also normality, like we assume that there's a normal distribution of the data set. So now we're going to do some practical examples. Yeah, guys. So the first thing that we'll be testing is the homogeneity of variances, and to do that, we'll be using either the graph method or we'll be using the results of Bartlett's chi-square test. So for the graph method, they'll give you a graph which is going to look something like this, or is going to look something like this. Then if the graph looks something like this, basically what you do is you draw a line from the first point to the last point, something that looks like this, and then you're going to draw another line for this one as well, and then draw another line for this one as well. So if you look at these three lines, you can basically see that the lines are somewhat different. They won't be like, I mean, they are somewhat the same. They won't be exactly the same all the time, but if the distribution is not that much different, then we're going to say that we assume that homogeneity of variances is met. We assume that the variances are homogeneous. Basically, we assume that the spread of the data is equal among the groups. Now, if it's something like this, you're going to draw the line as well. You draw the line for this one as well. You draw the line for this one as well. If you look at these three lines, they are all different. They are not equal. So now, in this case, then you're going to say, we assume that homogeneity of variances is not met. We assume that the variances are not homogeneous. So this is when they ask you about the graph, only about the graph. And then if they ask you about the homogeneity of variances using Bartlett's chi-square test. So in each question paper, you will see there will be the results of Bartlett's chi-square test, and then whereby you'll be having the test statistic, the degrees of freedom, and the p-value. So what's important is the p-value in this case. What you're going to do is you're going to write your null hypothesis as always, H0, and your alternative hypothesis, which is HA. So for the null hypothesis, we're going to say variance 1 is equal to variance 2, variance 2 is equal to variance 3. So remember, I'm still using the same examples of uh, the groups whereby one group is attending the sessions, one group is watching videos, and another group is doing self-study. So this is the case. And then for the alternative hypothesis, I prefer to write it in words and say variances are not homogeneous. So you can also write your null hypothesis in words and say variances are homogeneous as well, but I prefer to write it like this, and the alternative and say variances are not homogeneous. And then from there, what you do is you look at the p-value. In this case, this is the p-value. So the p-value is equal to 0.5233, and then the alpha is equal to 0.05. Now we can literally see that the p-value is greater than alpha. The p-value is greater than alpha, 0.5, 0.05. So p-value is greater than alpha. If the p-value is greater than alpha, what do? You do not reject the null hypothesis. You do not reject the null hypothesis. That's basically how you test this. And then the conclusion you're going to make is you're going to say, therefore, variances variances are homogeneous. So basically, this is how you do homogeneity of variance test. You do it like this. If you're given the graph, you do it like this. And if you're given the Bartlett chi-square test, or you ask based on the Bartlett chi-square test, this is how you do the you test whether the variances are homogeneous. If let's say the p-value was less, then you'd say the p-value is less than alpha, and then you'd reject the null hypothesis and claim that, or assume that the variances are not homogeneous. But in this case, we say the variances are homogeneous. So this is one of the tests of, one of the assumptions and one of the tests you need to know from slide unit 4. Now, one other thing that you need to know from slide unit 4 is what we call, okay, I had actually done this before. Let me just erase it. So yeah, another thing you need to know is, you need to know Tukey's groupwise comparison test, something that looks like this. So you need to know Tukey's groupwise comparison test. And for Tukey's groupwise comparison test, if you remember, when we started studying it 4.1 or part 1, we said that we say the group means are the same. For our null hypothesis, if you remember, we said the null hypothesis, we said the mean 1 is equal to mean 2 is equal to mean 3. That's basically what we did. But then the alternative we said on the hypothesis, alternative hypothesis, we said at least one is different. We said at least one is different. We said at least one is different. Now, when it comes to Tukey's groupwise comparison test or Tukey's HSD test, we're actually testing which groups are actually different, because we just said at least one is different, but we don't know which one is different. So now here, what we do is we test which one is actually different. Now to do that, they will give you the matrix of Tukey's groupwise comparison test. It's going to look something like this. So now, looking at our example, we have videos, tutoring, and self-study. Now, this is group 1, this is group 2, this is group 3. Group 1, group 2, group 3. We compare one group against the other group to see which one is different and which ones are actually the same. Now, to do that, we write the null and alternative hypothesis. U0, and then you say, H0, U1 equal U2, mean 1 equals mean 2. We assume that they are the same. The alternative, we assume that they are not the same. And then we look at the p-value. The p-value given is 0.0001. So this matrix is based on the p-values. 0.0001. The p-value is equal to 0.0001. So it's less than alpha, since we're using 5%. So the p-value is less than alpha. Then we reject the null hypothesis and say group 1 and group 2 are different. And then we go and look for the second one, which is group 1 and group 3. We compare group 1 against group 3 now. So we find that we first say they are the same, and then the alternative we say they are different. The same we did with group 1 and 2 as well. The p-value for this one is 0.003, which is also less than 0.05. So I made a mistake here. It's actually less than 0.05. Therefore, we reject the null hypothesis and say group 1 and group 3 are also different. And then we go and do group 2 and group 3 as well. So for group 2 and group 3, we say they're equal for the null hypothesis, and then we say they're different for the alternative. The p-value is less than 0.00001. So meaning that is less than alpha, and we also reject the null hypothesis. And when I say group 2 and group 3 are different, that's basically how we compare the groups against each other. Now we say at least one is different. And then if the question come and say which groups are statistically different from one another, you're going to say all the groups are statistically different from one another in this case. And then if they say which groups are the same, you're going to say there's no groups that are the same in this case. Now you might find in other question papers, let's actually go and look for a question paper from the previous years to just make this practical example where you have similar groups. So I'm just gonna look for past exam papers, NWU, just gonna search it like that. Let's go to 2015 to 2020. I'm specifically looking for test 2019. Yeah, let's do 2019. So in a 2019 question paper, so when it comes to this, it depends on how the question is structured. So okay, this is one way analysis of variance. You can see this is the matrix of Tukey's groupwise comparison. Let me just take a screenshot of that. Let me just take a snippet. Control C. Let me go here. Let me just make some space. Sorry. Let me just make some space and say Tukey's groupwise comparison test. So if we are to do the same thing for this, we're going to start by saying, okay, let me just make this here, and then okay, just gonna control C, control V, control V. Okay, so that we have 3. So we have to compare each group against the other. So we're gonna do the same thing here that we did for that as well. So let me just zoom this in so that I can actually write better. 80. We're gonna say group 1 is equal to group 2, and then alternative hypothesis, we say group 1 is not equal to group 2. Okay, so let's do the same thing here. Here we're going to say the null hypothesis, and then we say group 1 and group 3. Group 1 is equal to group 3, and then alternative hypothesis, group 1 is not equal to group 3. Now let me just do for the last one as well. So it's going to be group 2 and group 3. Null hypothesis, alternative hypothesis. Group 2 equal group 3. And then we say here group 2 is not equal to group 3. Now from here we know that we're going to write the p-values for this. So the p-value for group 1 and group 2 is 0.0001. So you're going to write it here and say the p-value is equal to 0.0001. Therefore the p-value is less than alpha. P-value is less than alpha. Therefore we reject the null hypothesis. The null hypothesis. We reject the null hypothesis. So if we do that, then we're going to say group 1 and 2 are different. Group 1 and 2 are different. When I say group 1 and group 2 are different. So for group 2 and 3, we find that for group 1 and 3, sorry, for group 1 and 3, the p-value is equal to 0.1812. So if the significance level is 5%, the p-value in this case is greater than alpha. Therefore, what do? You do not reject the null hypothesis, and then you're going to say group 1 and group 3 are the same. When I say group 1 and group 3 are the same, then you do the same for group 2 and group 3 as well. If you look at group 2 and group 3, you see that it is 0.002. So what you're going to do is you're going to do the same thing that we did for the other groups as well. So it's group 2 and 3 here. So here the p-value is 0.0002. So it's 0.002, Therefore, the p-value is less than alpha. And then if the p-value is less than alpha, you reject the null hypothesis and you'll say group 2 and group 3 are different. You're going to say group 2 and group 3 are different. Now, this is how you do Tukey's groupwise comparison test. From here, you're going to check what the question is saying. Let's take an example from this and look what the question said in this case. It said, let me just take a screenshot of this as well. The question was asking you are the group means for method 1 and 2 statistically equal? So equal means the same. So they're asking about group 1 and 2. They say, are they statistically equal? Then after doing this, you can see that no, they are not equal, they are different. Then you want to say no. State the relevant p-value. The relevant p-value is they said group 1 and 2, method 1 and 2. Yeah, so this 1 and 2. So you're going to say they are not equal. So you're going to say no. State the relevant p-value. The relevant p-value in this case was 0.0001, and the null hypothesis that is rejected or not rejected. So that is the null hypothesis. Basically meaning in this question they wanted you to write this part of Tukey's groupwise comparison test only. So they just wanted you to write this. So you're going to say no, they are not equal. They are not equal because the p-value is less than alpha and it is rejected. So it depends on how the question is structured when it comes to Tukey's groupwise comparison test. For example, they can say which groups are the same. So you're going to say group 1 and group 3 are the same. They're going to say, they might say, are group 1 and 3 the same? Yes. Write the null and alternative hypothesis. This is the null and alternative hypothesis. Give the relevant p-value. This is the p-value. Make a decision. This is the decision. P-value is greater. You do not reject the null hypothesis. And then you say group 1 and 3 are the same. And then sometimes they can say which groups are different. They just say which groups are different. In that case, you're going to say group 1 and 2, group 1 and 3 are different. Ne? So to answer that question short and simple, you can say all the groups are different except for group 1 and group 3. All the groups are different except for group 1 and group 3. So that is literally how you do the Tukey's groupwise comparison test, to check which groups are actually different, which ones are the same, and so that we cannot assume like we did in the beginning of analysis of variance. So that is basically study unit 4 in a nutshell, and I hope you guys understand. You can go through some of the questions. The last thing I want us to do is normality, which is where is normality? Yeah, which is here. So when it comes to normality, we're basically asking you, so they'll give you a graph. It's going to be this graph that looks like this or the graph that looks like this. If a graph looks like this, you can see that all the points are actually on that straight line or closer to that straight line. So if they're not deviating from that straight line, you're going to say there's a normal distribution of the data set. So basically normality is satisfied in this case. But then in this case, you can see that there are points that are far from that line. There's even this one that is very far from that line. So it's possible that even if that is the case, you can find maybe there's a point that is somewhere here, or there's a point that is somewhere here. As just 2 points, and they are not that far compared to this point and that point over there. So in this case, you can still say normality is satisfied, and then if it's like this, you'll say normality is not satisfied. So this is about the normal distribution, and this is how they can ask this question. They will say, is normality satisfied? Give a reason for your answer. So you're going to say, if it's this graph, you're going to say normality is not satisfied. And then if they say motivate your answer, you say, I mean, you're going to say normality is satisfied. Motivate your answer, you say the points are lying closer to the straight line. And then if it's like this, you're going to say no, normality is not satisfied because there are still points that are deviating from the straight line. There are still points that are far from that straight line. And that is study unit 4. If you feel like there's something that I missed, you can just ask that question in the comment section, and I will answer that question. Otherwise, just go through some previous papers and practice this often, and you guys should be fine. Otherwise, I'll see you guys in the next video when we do study unit 5, which is going to be the shortest video ever. So yeah, thank you guys for watching, and good luck.